is not a vector that its direction changing will affect our answer. Correct. That's why we are having this. So E1, E2, E3, here we'll have minus E2, wherever the reversing of the cell has occurred. Now see, this is the question. The three cells are connected. We have to find out current through each cell and terminal potential difference across the 10 volt. So terminal potential difference across 10 volt and current through each. Look how will we calculate. Firstly, we require total EMF. E equivalent will be, see, all are connected in the same manner, plus, minus, plus, minus, plus, minus. Had I seen plus, minus, minus, plus, and plus, minus, or minus, plus, plus, minus, plus, minus, then it would have been different. Right now, everything is in symmetry. So it will be E1 plus E2 plus E3. This is equal to 10 plus 5 plus 15. So this is equal to 30. Now when we are calculating the R equivalent, that will be R1 plus R2 plus R3. So this is 1 plus 2 plus 2. So this is equal to 5 ohm. Now when we are calculating the total current, across this, so for total current, what we'll do? Total current will be total EMF, that is 30 divided by, what's the value of capital R? 10 ohm. So 10 plus what is the value of total internal resistance? 5. So this is 30 divided by 15. So your current is simply 2 amperes. Terminal potential difference across 10 volts. See, for terminal potential difference, yesterday also in the last class I've told you, E minus I R you have to write. E equivalent is 30 minus current total is 2, the equivalent resistance is 5. So this is 30 minus 10, which is equal to 20. This is how you have to deal with the entire case of reversing of cell, the numerical and the combination. So do not write series and parallel combination. Make the heading as combination of cells. First write it down, then we'll come to that later. First start writing from here. Any queries, let me know, because Taha, you have joined late, because I understand you must be coming from school lately, but it's okay. Just tell me if you have any doubts. Start writing from here. We have started from here only, Taha. Yes, class. So see, coming to series combination and parallel combination. Now, one thing we have already discussed in the chapter capacitance. Capacitance, we have discussed how to solve the questions of capacitors. So same thing, see, their charge remains same in the series case. Here in the series, the current is going to remain the same. If you see, if you see the current is remaining same in all the devices, then your current is indicating the fact that it's a series combination of all the resistors. And if the voltages are same, then it indicates that it's a parallel combination of the resistors. So it's very easy. See, different resistors are present, different voltages are present. Let's calculate the net voltage. It's V1 plus V2 plus V3 up till Vnth. So what is V according to Ohm's law? We know according to Ohm's law, V is equal to IR. So this is I into R equivalent, I into R1. Why I is not changing? Because it's a series combination, and in series combination, current is remaining the same. Current remains the same. I R2 plus I R3 up till IR N. Current will be cancelled. So R equivalent is R1 plus R2 plus R3 up till Rn. It means you just have to algebraically add for the equivalent resistance. Now, when you're calculating current through each resistor, I1 is equal to I2, which is equal to your current I. Means current is not changing. Voltage through each resistor. See, voltages can be different. Current will be the same into the resistance. If you're calculating for a second resistor, so current into that resistor. Or if there's a third one, so current into R3. So basically, Vnth is equal to I into R. Yeah, power dissipated is also important. P is equal to I square R. So here, when you're calculating power 1, so R1. Similarly, this is R2 like this. Also, you can use one more formula. P is equal to V square by R. That also you can use. Same answer you will get. Okay, same answer. So for power also P and F, it will be I into R. Now this question you all are going to answer. It's a very easy question. All the parts you will be answering. Very easy. It will just take you 2 to 3 minutes to answer this. First write it, then we'll start with the parallel combination. Okay, look. What is the answer for the first part? At least the first part should be answered by both of you. Anyone? What's the answer for the first part?
15 ohm.
Yes, Zara, say
15 ohm.
15 ohm. Perfect. See, R equivalent will simply be R1 plus R2. You don't have to stress here. 5 plus 10 straight away. 15 ohms. And if you're getting the answers and still you're not answering, then that's very bad, and a bad feedback will be sent to your parents. That's why I always say keep on answering in the class. If not by unmuting yourself, at least answer in the chat. So second part says total voltage. Yes, class.
I just finished solving it right now, so.
Okay. Okay. See, total voltage, in total voltage, you don't have to solve anything actually. Both of you. Why? Because total voltage is already mentioned. This is the total voltage for the entire circuit. So total voltage is 10 volts. Total voltage is 10 volts. Third part, let me discuss, then you all can write. Total current. See, total resistance I have, total voltage I have, total voltage into total current into total resistance. 10 current is, we don't know. R equivalent is 15. So what is current? 10 divided by 15. This is 2 by 3 amperes. Fourth is voltage across each. Yeah, this is something different. Voltage across each. See, V1 will be I into R1. 2 by 3 into R1 was 5. So that becomes 10 by 3 volt. And V2 becomes I into R2. That is 2 by 3 into 10. So this is 20 by 3 volt. You can even check. See, 10 by 3 plus 20 by 3 gives 30 by 3, which is equal to 10 volt. Means our answers are correct. Last part says current across each. Current across each, it's a series combination. In series combination, I1 is equal to I2, which is the total current, that is 2 by 3 amperes. All right, write it. Then we'll start with parallel combination. See, now when we're talking about the parallel combination, in parallel combination, the voltage remains same and current is different. So when we're talking about the currents, the equivalent current will be I1 plus I2 up till I and N. So you know V is equal to IR. So current will be equal to V divided by R, right? This will go here. So voltage divided by equivalent resistance, V1 divided by R1 plus V2 divided by R2 up till Vnth divided by R. Oh, sorry, not V1, V2. Voltage will be the same. Because it's parallel combination, so voltage will be the same, remember. Voltage will be the same. If it's V here, it will be V all over. So potential will be cancelled. 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 up till 1 by Rn. All right, so this is the equivalent resistance. Basically, you have to reciprocally add all of this. One more thing, see if you're calculating the potential, V1 is equal to V2 is equal to V. If you're calculating the individual currents, so I1 will be V divided by R1, I2 will be equal to V divided by R2, Inth will be equal to V divided by Rn. And when you're calculating power, this is I1 square R1. But that's why it's better here in this, instead of using current, for power you use V square by R1. P1 is equal to. P2 is equal to V square by R2. So your Pn is equal to V square by Rn. Let's see one question also. Or do one thing. You tell me the answer for that question. One question we have discussed similar. Memuna, this time you also will try to answer, okay? Write it.
Okay.
Yes. What's the answer for the first part? Okay, Zara has answered all the parts. Very good.
15, ma'am.
Yes, Mamuna. You also type the answers so I can compare it also.
Okay.
Just type it. Just type it. At least the first part, quickly write it. See, till the time she's mentioning. For equivalent resistance, it is 1 by 5 plus 1 by 10. So this is 2 plus 1, 3 by 10. R equivalent is equal to 10 by 3 ohms. 10 by 3. Okay, second part you have answered. Memuna, first part's answer is this. Zara's first part is correct. Yes, second part, both of you have given the correct answer. Total voltage is 10 volt. Third part, total current. If you have the total voltage, you have the total resistance. Total current is very easy to calculate. It is V divided by R. 10 divided by 10 by 3. So this 3 will go up. So current is equal to 3 amperes. Total current is 2 by 3. No, how 2 by 3? Memuna, see, voltage is 10 volt. Current is 10 by 3. So how are you getting 2 by 3? 10 will be cancelled. Only 3 amperes will be left. Voltage across each. This is a parallel combination. So voltage across each is not difficult. V1 is equal to V2, which is equal to the total voltage. That is 10 volt. So Zara has answered this also. Okay, last part. Current through each. Voltage is 10, resistance is 5. So 2 amperes. 10 and second is 10. That is 1 ampere. And see, when you add it, 2 plus 1 gives you 3 amperes back. This also checks the calculation. So I1 1 ampere, I2 2 ampere, and total current 3 ampere. Very good, Sarah. All the parts are correct. Write down. Look at this question. How will we start? Whenever two free ends are mentioned, class always assume that there's a battery which is given. That's why this is mentioned. If 2 points are given and you are asked to calculate the potential or total current or total equivalent resistance or anything across free ends, it means the battery is connected between these two ends. We'll start from this end. So see, these are two resistors. They are connected in parallel. So 1, 2, so R1 and R2, they are connected in parallel. See class, when two identical resistors, or not just two, number of identical, these are all are identical resistors, means having same value of resistance. Then in parallel connection, just take the value of resistance and divide it by the number. Means like I want to calculate R12, equivalent resistance between 1 and 2. So I'll write it as R by 2, means resistance, given resistance divided by the number of resistors. Okay, that will help your answer be very quick. Like if you look at this, suppose these are connected in parallel. They are connected in parallel. So this becomes R. So this becomes R by 3, like this in such cases. So this is R by 2. Okay. Now, instead of these two, we have replaced it with R2. What is the next connection possible? Next connection possible is these two. So we can see that R12 and R3, they are connected in series. So R1, 2, 3 will be added. Basically, it will be R plus R by 3. R by 2 is the resistance. So we can replace this with just 3R by 2. Okay, so we have replaced this with just simple 3R by 2. Now further, these two, they are connected in parallel combination. So R1, 2, 3 and R4 are connected in parallel. So 1 by R1, 2, 3, 4 will be 1 by R1, 2, 3 means this 3R by 2 plus 1 by R. So this is 2 by 3R plus 1 by R. So this is 3R. This is 3 plus 5. So equivalent resistance is 3R by 5. R1, 2, 3, 4 is 3R by 5. So we replace this and put this as 3R by 5. Now when all of these are present, you add all of these together because all of these are in series now. R1, 2, 3, 4, R5, R6, all are connected in series. Now R1, 2, 3, 4, 5, 6, instead of that, we have the final equivalent resistance, where this is R plus 3R by 5, which is 2R plus 3R by 5. So this is 5, 7R plus 3R. See, this is R plus R is 2R. 2R plus 3R by 5. So 5 gets multiplied here. Oh, that's 10. Wait. This is 10, so this becomes 13 r by 5. That's that. Tell me the entire steps, all the sequence, and how to calculate these cases. Is it clear, Sara and Memuna? Zara and Memuna? Clear?
Yes, ma'am.
Memuna, what about you?
I'm here.
Okay. Start writing. If you have any queries, please ask.